This week's lesson is on vertical adaptive music, and I think to best understand it, it's helpful to do a little review from the last lesson we did and just reiterate what it means to have horizontal adaptive music. This is one of the examples from that last lesson with Bolero. And it's a great example of horizontal adaptive music because as I change the value of the parameters up here, we're jumping in this timeline, moving from the intro of the song to this first section where the flute plays a statement of the melody. And as we pass these little green navigational markers along the way, they signal where this song could go next, depending upon what conditions are met. So for instance, if we're still in marker A, I could stick in the A section. In fact, let's just go ahead and let it do that. It's going to pass this green marker right now and jump back to letter A and play this flute melody again. But if I change this condition here and say, okay, we're ready to go on to marker B, well then, once it gets here to this transition marker here at bar 13, it will go ahead and jump ahead to marker B, and we'll hear a new statement of the melody, this time played by the clarinet. And that's really how the horizontal technique works, is it allows you to jump back and forth in time and hear different sections of the song, potentially in different orders. This particular implementation of Bolero doesn't do that, but there are ways to set it up that way. By comparison, let me switch to this track. And I'm just going to go ahead and play this, and then we can talk a bit about what's going on. You'll notice as I play through this that I change the value of condition. Condition has 5 possible values. They grow in intensity. So condition 1 is more mellow, condition 2 ramps up, condition 3 reaches the maximum intensity, and then conditions 4 and 5 step back down. And in condition 5, you're at a moderate level of intensity that matches what we heard with condition 1. Let's hear what that sounds like. And again, this is a vertical adaptive music technique. And there we are, and I'll just stop it there while we sit in condition 5. And so you heard that piece of music go through 3 different layers of intensity and grow as instruments were added and subtracted from the mix. Well, this example, the music is by Chance Thomas. It was something that we did together to support his book, Composing Music for Video Games. And this is a demonstration of what he calls the layered loop technique. Now, there's a lot to talk about here. I'm not going to go into a lot of the technical particulars, but I just want to use this as an example of how the vertical adaptive music technique works. So in short, if I open these up, you can see that we have some automation here in Fmod. And what's happening is when we play this game back and our parameter has a value of 1, it's just going to sit here in the condition 1 section because that's the current game state. It will loop in this region And because we know how Fmod works, we understand that, well, while it's looping in this region, we will hear whatever audio is audible as the playback needle makes contact with the instruments that are in this section. Well, right now, loop layer 1 is audible. Its volume is at -2 dB, but audio 2 and audio 3 are both all the way down, so we can't hear those at all. But when I change the condition here and we move to condition 2, well, this transition region sends us on to condition 2. We hit that marker, continue to play, and ramp up the automation, and then suddenly we're into condition 3. And we're playing this, we're into condition 2 and we're playing this loop. And at this point, audio 1, its volume hasn't changed. It stays at -2 dB the entire time. But now we actually have some volume, 1.52 decibels, and we're now at this point, we're listening to both of those loops at the same time. And let me just go ahead and do this one in real time. I'm going to change this to condition 3. And as soon as I hit the enter key on my keyboard, you'll see this playback needle jump to the marker, play through. This automation ramp will come up, and then we'll be able to hear the audio that's there in the third track. Here we go. And it's a totally smooth transition, completely seamless, without any interruptions whatsoever. And what can be kind of counterintuitive about this is the fact that we're playing back this little section that's just looping within 1 bar of space in this timeline. But in reality, if I zoom out, we can see that there's a ton of audio in this. Chance compose about 1 minute and 40 seconds or 38 bars at this tempo of music for this. And as asynchronous events, so you can't see this because I don't have the deck up right now, but there we can see, as asynchronous events, each of these loops will just continue to play and loop in this section based on what's audible, no matter where we put the condition. Whoops, I put that the wrong one. So I put condition 4, and now we're looping here. Hide the deck, and now we're just able to hear what plays in these first 2 tracks. And when composers start to work with music in this way, they often use what's called a reductive approach. So they will actually hear something more like what we hear at this point. Oh wait, I want to say, yeah, condition 3. So they will work on the piece and be able to hear the full intensity of the music. So right now in this version, we can hear all 3 of these tracks. Ultimately, this is many more individual instrumental tracks in the original composition. And this is a good way to start with something like this. But then when working towards the vertical technique, composers will start to pull those voices out and think about how to simplify the overall intensity of the music so that you can set it up and have it play in a scenario like this and allow things to vary between, a low or mellow intensity and something that's much higher and much more, has a lot more emotional weight, dramatic weight, or whatever it is that the particular game level calls for. So obviously these techniques are related, but there are some really important nuances. So just to revisit this again, here's our horizontal technique from last week. And probably, it's important to remember that the horizontal technique jumps in time. Allows you to go earlier or later in time so that you can hear different sections of a song, and it allows you to freely mix and match those sections, which means you're taking a combinatorial approach that allows you to have a continuous set of revisions to the order of the individual sections of the song. And this is probably most audible if we go to this version of Bolero that I did in the last lesson that uses these magnet markers, where we can play Bolero and go through the intro and jump to any section. So let's just jump here to letter C. What do we get? We get the statement of the melody by our bassoon. Then we can jump back to the first section. And we pick up right where that bassoon left off, more or less. Statement of the melody, but this time played by the flute. We can jump to our last section here. And we just continue to bounce around from one section to the next. And you know, in this horizontal scheme, we're getting different versions of the song, but we're moving left to right in time horizontally in order to get those variations. By comparison, the vertical technique, and this is really visible when we can see it like this with the automation open, the vertical adaptive technique modulates the mix. It's like having the control of a DAW inside your game. So what a player hears, you know, which tracks you hear, at what time and how much, you know, that mix overall is controlled by parameters inside the game. And so that's what this lesson is all about. And I want to show you a couple different ways to think about doing this in Fmod so that you can use this idea, because it might be better for the music that you've written, or it's just more responsive for the kinds of interactions that are in the game that you're working on. So let's take a look. I've got another file here, and this is, you know, kind of a rudimentary, just the raw material of vertical adaptive music scheme. It doesn't sound great, it's not all that musical, but it's really functional, and I'm using those basic waveforms that I did in the previous lesson, which make it really clear when you listen for transitions from one section to the next. And this uses the vertical technique. So here we are just looping a sawtooth wave. It's playing a consistent pulse. I have a gain parameter up here, and I want to move on, so I change that parameter to sine, and we'll now be able to hear the sine wave. And you can hear, you know, whoa, that jump was really, really pretty harsh. Jump to the square wave. And that one was a lot smoother. Well, this event isn't finished right now, and part of what I want to show you in the lesson is how this is working. We can fix some of those transitions that were a little bit harsh and abrupt, show you how to make this work, and with these basic waveforms, I think it provides a good example. And then we'll go from here, we'll take a look at something that's finished to really put all of this together and look at how you can use a number of the options that we've talked about in this lesson series to build something that really has a lot to offer the listener and really responds to the variety of interaction that the game also has to offer. So let's see where to begin. Well, we've got these individual loops, and you can see that we have automation. And these transitions are there. But one of the things that we're really not doing here is taking full advantage of the automation that's here. Right now, this region is going to jump to the sine wave marker, but the sine wave marker is there, so we're skipping playback of this whole section and not taking advantage of the crossfade that happens right here in this middle. And that's really what we want with this vertical technique, is to have these smoother transitions where one track can duck out where the other one fades in. We create a smooth crossfade, and the transition can be, almost imperceptible. But that's not going to work if our playback jumps from here to here. And just in case you didn't catch that the first time, Let's take a look and see. So here we are, looping in Sawtooth. I'm going to change this to sine and watch it jump over here to bar 3 when I make that transition. Yeah, and it just jumps right there to sine. Not terribly smooth. But if we move this marker back and do the same thing, we'll be able to loop, but then we make the transition, gets to the end of the bar, and our first sawtooth wave continued to play at that point, but it went away over the span of a bar. Our sine wave came in and we ended up there, and it's completely smooth. Well, you'll find we have the same thing here with the square wave. We jump to square, and it just jumps there immediately. That one didn't sound quite as bad, but we also didn't get that smooth crossfade. Well, in order to get the crossfade, we need to move square back there and then double check our animation, our automation. We can see, yeah, there, look. So when we jump to square, that's going to allow the sine wave to fade out, the square wave to fade up, and then it locks into this loop region after having taken a bar to crossfade between those few. Smooth transition to our sine, and then we should get a smooth transition to the square. Exactly. Good. So let's look at how we'd continue to build this out and have a transition with a crossfade going to our noise wave. So from the square to the noise, and then also from the noise to the section at the end called all, where we'll let all 4 of these waveforms be audible at once. Well, the first thing we know we need to do is to move this marker back to a point where we can create the crossfade. And then once we have the space, we actually need to create the automation. Now, right now, you can see that noise is stretched, and actually I should have probably pointed this out earlier. You can see that all of these individual instruments, saw, sine, square, and noise, are in these yellow regions, which is FMOD's, seems to be the default color for instruments that are nested inside others. And by that, I mean I can double click on this and it actually takes me into this instrument called noise. Well, this is set up with its own loop region, tempo marker to match, and you can see there's the 4 pulses of this noise wave. So it has its own internal timeline. But when it's running here, it means that for as long as FMOD's playback needle makes contact, it will play whatever is audible in this region. And even though in this section I'm only looping within the span of a bar here, it will still allow this instrument to play its timeline, and in this case, loop it because I have this loop region set right there. So even though it's only looping within a single bar right here, it will play the entirety of the audio that's in this instrument as long as it's making contact right there. And so that's how we can have timelines like this that seem impossibly short given the length of the musical events that are in them. And it's not that we're doing anything too terribly odd. It's just a matter of the length of those musical segments being kind of hidden away or tucked away in a sub-event that we don't see when we look at it on this timeline. But with that in place, it means that I can continue to loop this section, and I have a loop marker that's right there. But what I don't have is the automation that allows that to happen. So I need to add it. So I will right-click on volume, choose Add Automation, and it brings this automation curve in. I can just click right there, and then bring this up and let that just go ahead and go to full volume at 0 dB. So there is my smooth crossfade. When we cue for this to go to noise, it will play this crossfade right here and then get locked into this loop. But if you look at our timeline closely, you realize, we don't actually have anything that would allow that transition to happen. I can let this play, and it's going to loop, but when I say I want to go to noise, there's nothing in this timeline that's going to respond to that parameter change. And that's because I don't have a transition region in here. So let's right-click, add a transition region to the noise marker, set that up so that the volume, or sorry, so that the duration fits this, and then we need to add a condition. What parameter condition are we looking for? Well, we're looking at the wave condition, and we want to jump to noise when noise is what's selected as that parameter. So let's reset this to square, play back. We can loop in this section. We change the parameter to noise, crossfade, and we get our noise wave. Exactly as we wanted. Good. So now we have one final section, all, and this is where we want to be able to hear all these instruments at the same time. Well, based on what we've just done, we can simply repeat the process. We need a destination trigger, so we'll add a transition region to the all marker, make that available within the loop. We need to tie that to a condition, so we can do that down here in the deck. Parameter condition is wave. We'll look for wave to be set to all. When all is selected, it's going to jump here, but as we discussed earlier, we don't want it to jump right to the beginning of that loop. We'd like to take advantage of a crossfade, so let's bring that back. And just for the sake of example, I'm going to make this one half as long as the others, just for the sake of doing it that way. So let's look at this. Well, noise is already playing, so we really don't need to make any changes there, I don't think. But square wave is not playing, so we'll click, whoops, I didn't want that there, I want that there, and then we'll add another point, and we'll bring that up. And these are all going to play at the same time, so let's keep these a little under where they were. Same thing here with the sine wave. We jump to all, so we want the automation to begin there, but then go up and be set at a higher volume when we get to the loop. And it looks like this is already set here for saw wave. All right, all four of those are good to go. So there's our transition. So we're locked into looping here with the noise wave, and let's choose a parameter and go to all. There we go. And at this point you may realize, oh, some of those are a little louder than I'd like them to be. Well, or maybe not loud enough, so we could boost the volume of our noise wave. We could bring down the volume. And you get the levels set exactly where you'd like them to be. And establishing those automation levels, making sure that the balance is exactly where you want it to be, is really what this part of the technique is all about, because ultimately we're really just trying to decide, based on whatever game parameter happens to be present, whatever our current game state is, we are going to mix the level of all of our individual audio elements so we hear the right combination at the right level. And as the game state changes and our parameter value shifts, that mix will shift accordingly, and we move to a new mix that's more appropriate for whatever changes may have just happened inside the game world. And that's really all there is to it. So it's similar to the horizontal technique, and we are jumping left to right in a timeline, but recognize that by jumping like that, we're just simply moving to different locations where the automation data has been changed. And that allows us to hear these elements with a different balance, a different overall mix. So this was a pretty raw and mainly just functional demo, but let's take a look at something that's more musical, something that we can put into a Unity project. I have this other event right here. It's called Game Music Main, and let me just go ahead and play through this. This is done. I'm not going to make any changes to this, but I'll just play through this so you can hear it, and then we'll start to break it down and talk about what's going on with the various steps that I've taken here to implement these ideas and use the vertical technique to make this music come together. So it starts off with the idea that we did a few lessons back, the idea of an intro that goes into a loop and then to a tag. But the difference is that because this is vertical adaptive music, we have different sections here in the loop. And so I go from this intro with just drums and a bass, and I add this kashishi. We go to our next condition, and we get the berimbau and some bongos. So that says bongos, but I'm pretty sure I used a cajon. Next condition. We get a synthesizer pulse. Fourth condition has more of a melody that takes over. And the final condition brings all of this to a close. But I didn't want it to just end. So just before it seems like it's going to fade and go away completely, parts of this music start to come back. The overall mix is limited. It's a little distant and ghostly sounding. But we still have some of those elements, and I labeled this as the reprise section, where it's something that's just going to play after a player's task is finished before they decide to move on to the next level or whatever may come after their current location in the game world. So let's take a look at this. To make more room for this, I'm going to clear some of these UI elements so we can see more of what's going on here. Well, let's see. First of all, game parameters have two different things. Started, yes or no. And that's simply what cues the very beginning of the main section of the music. So when this starts, we are here just playing this intro loop. We're assuming that started equals no. And so we're just going to hear this section. And when I change that to yes, it jumps ahead. You'll notice that there's a stinger that plays immediately. The parameter started has its own parameter sheet, and you can see a stinger is in its own track right here. Here's the stinger instrument. It lines up here in this parameter sheet when the parameter is equal to yes. It is just a simple wave file with that little kind of ethereal synthesizer that plays over the top. And so simply that means is that as soon as the started parameter is set to yes. This timeline jumps to this location. It means that it makes contact with this instrument, and so it plays our stinger. So that's what happens. And then when we get to the next quarter note, so the stinger will play whenever the parameter is changed, but then based on this transition region, on the next nearest quarter note, it's going to jump to start. And then we step in here to our first loop. And this is where the vertical technique comes into play. So imagine that we're looping in this section and obstacles parameter is set to none. It's not going to move until we've collected one or smashed into one obstacle in the game. So it will continue to loop in this section, and let's take a look. What's audible at this point? Well, we can see this drums and bass track has its volume at 0 dB, but the kashishi, bongos, synth, those are all silent. So we don't hear those. Until we change the parameter to 1. And at that point, we jump into this next section. Well, what's happening here is more or less identical to the other vertical adaptive techniques that I've talked about in this lesson. Drums and bongo, you can see its automation doesn't change at all here. That volume stays exactly the same. But here, the kashishi, as soon as the parameter changes, we jump to few on the nearest 8th note. Few marker is right there. You can see it anticipates this loop region, but when it does, we get a quick fade up, and that kashishi comes in over just a single beat, and then we're into this new loop. But at this point, kashishi is playing full volume, but our other tracks, berimbau and the rhythmic synth, nothing happening down there. And so we don't hear those tracks. You'll notice that they are still running. You can see individual timelines for both these tracks playing through. And that little white playback needle that's inside the sound instrument itself gives you a really clear idea of how it has its own internal timeline and how it's playing. But because our playback needle is making contact with both those instruments right now, they're allowed to play, but the volume is all the way down and we just simply can't hear them. Until we change the gain parameter and we jump to 2, and you can see there, 2 means, well, we're going to jump to some. So we jump to this marker. We can hear that cajon and the berimbau. We look at the automation for that track, and you can see same thing. At that marker, we have a quick fade up over a beat, and then we're into a new loop region. But in this loop region, these 3 tracks are all audible. And at this point, what comes next probably makes a whole lot of sense without explanation. We're going to change parameters. We're going to jump to the more marker. As we do, it's going to hit this automation curve, and it's going to quickly fade in the synthesizer, and you'll hear that rhythmic synth. And that is allowed to play and loop just like the others. We have a couple more conditions and a couple more locations in our timeline. If I change this and bump it up one more, we've smashed into 4 obstacles, let's imagine. We go to the next marker. No fading at this point because I really wanted this melody to just happen right on a downbeat or right on an immediate beat. I didn't want it to fade in from out of nowhere. And so just allowing it to start right at the beginning of this section works. And you'll notice that this one, rhythmically, really just kind of seems to be doing its own thing. And that is exactly right. It is doing its own thing. take a closer look at how and why that's the case a little bit later. But we still have another condition after we've smashed into the fifth and final obstacle. When that happens, you can see we're going to jump to all. So we'll jump to this marker. And based on the automation that's there, you can see that we fade out all of our tracks. We play this little bit of audio that makes our outro, and then slowly start to fade in a couple of the instruments that are here over several bars until we get to the reprise. And then once we step into that section, we have a new version of this Europa Melody that's playing down here that joins them. Let's hear what that sounds like. And you'll notice that this version of the music in the reprise, or I should say this section in the reprise, sounds a little distant and a little ghostly. Well, let's take a closer look at some of those things. Let's see, first and foremost, game parameters for this are all, let me choose edit parameters so you can see this. They're all labeled user parameters. And obstacles is in the name because that just made the most sense for the obstacles that we smash into in this tutorial. You smash into none of the obstacles, or 1, 2, 3, 4, or 5 of them. And one thing I should point out, I didn't notice this the last time I was using this type of parameter, that I was sort of bemoaning the fact that Unity didn't have any way to access these labels by name, and that's still the case as far as I know. But what I didn't notice is the fact that Fmod actually gives you a numeric value over here, and those values are consistent with what I found in my code with Unity. So even though at least I find it helpful to use these labels that are more intuitive, Fmod is sending Unity these numeric values that start with 0, move up in integers, for as many individual labels as you have. So we have 1, 2, 3, 4, 5 crates plus none, so that's a total of 6 labels with values 0 through 5, or 6 total values overall. And that's what we'll use later when we integrate this into Unity. This is identical to what we did with the last lesson for horizontal adaptive music when we were jumping around to different locations within the timeline. But I thought it was helpful to note the fact that Fmod did actually give us these numeric values. And I did more or less the same thing with started, that triggers the stinger when we're coming out of the intro and ready to go into this first loop section. Then, let's see, what's happening here? Well, let's work kind of from the end backwards. I talked about the fact that the music sounded a little distant or a little ghostly. And that's happening because we have some additional automation down here in the master fader. And let me open up the deck so that all of this is visible. Master track has a 3-band EQ on it. The high band is automated. You can see that by the little red dot that's right there. I set the high crossover frequency at 1.15 kilohertz with a crossover slope of 12. And that automation shows up right here in this track. And I'm not doing anything with it for most of what we hear throughout, the intro and collection of all the obstacles. And it's not until we actually collect the final obstacles, play through the outro, the reprise comes up, that this filter starts to kick in, and I pull that high frequency down about 13 decibels. And that's just essentially creating a low pass filter effect. And that's what gives this that more distant sound overall. And remember, because this is on the master fader, that processing is happening to all audio that's running through Fmod right now. So the synth track that's playing right there, and the kashishi, as well as this new version of the Europa Melody. So that's what gives that reprise that slightly different timbre compared to what we heard with this music earlier. Now, everything else about this really fits into what I've explained earlier. The way the parameters work, the way the fades work as we move from section to section. The only thing I really haven't covered at this point is the Europa Melody. And this is something completely new. And honestly, it's really not indicative of a vertical adaptive music solution, but just something that I thought would be kind of fun to do. And also, it introduces some of the key techniques that you might use if you were going to create generative or procedural music in Fmod. So, stepping out for just a second, you'll see that this Europa Melody gets cued when we jump here and play across. And so for as long as we're looping in this final loop region right here, we'll make contact with this instrument, and so we'll be able to hear what it does. Well, let's see what that is. Like our other instruments, it has its own internal timeline, and it's made up of 3 different multi-instruments. You'll notice that these get cued at different points, and the loop itself actually runs over an interval of 7 beats. And I did that in particular so that it would run out of phase with, what's probably easiest thought of as 2 or 4 bar phrasing with all of the other instrument parts that are in this music. So that's something that's going to add some variety and diversity to what's happening with the melody rhythmically. From a harmonic point of view, the multi-instruments are doing a lot. You can see that I have 3 of them here, and each one of them has their own collection of individual notes. And these were just notes from a synthesizer that I thought could be cued at random and create something with more melodic interest than any of the other parts that are currently in this music. The multi-instruments have a lot of individual settings that really help add additional variety to this whole scheme. Let's see, where to begin? Well, first and foremost, in the multi-instrument itself, you have the ability to set the playback percentage. And in this one, I have one note that is kind of a half step outside of the key of this song. It sounded good, and so I wanted to keep it in there, but I didn't want it to play as frequently as the others. So I set its playback percentage to be only 10%. So when this multi-instrument is cued, it will weigh the options of all the sounds that are in here, and 10% of the time it will pull up this A-flat 3 note. But the playback percentages of the other instruments is pretty well balanced. I could shift that if I wanted to prioritize some notes over others, and that's one of the things that makes playback percentages so helpful here in a multi-instrument. Also, all of these instruments are asynchronous, so you can see that that button is checked, which means that they'll all be able to run kind of on their own time within the span of this loop, and freely within the span of the loop that's on the game music main event timeline, where the rest of the music is hosted. The other thing that I've done to kind of create some more variety with these individual notes is to experiment with the start offset. And that's a setting here in the multi-instrument. I used start offset for this first one and for the second one. And I think the second one will probably make a better example. So right now, this start offset is set to 20%. So it means that it won't begin at the beginning of this, but it will start 20% into whichever audio file this multi-instrument cues. And if you look really carefully, you can see that there's that little additional bright green line right there next to the 20%. That lets you know that there's actually some additional automation and modulation on this. I've used the random modulation to make sure that that 20% isn't exactly 20% every time. So sometimes it might go a little over, sometimes it might go a little under, but it means that we'll always be getting something that's a little different. And to make that work, I just simply right-clicked. I chose Add Modulation Random, and it gave me this dial, and 20% here seemed to work well with the 20% that I had already set in the start offset. In addition to that, I also had to add some Ahdsr modulation. And that was because when we use start offset, we're basically jumping right into the middle of an existing wave file. And you never know where that's going to be. If it ends up starting that sound at a place in the audio file that is not a zero crossing, you're going to get a snap or pop or some other weird artifact. So I used Ahdsr to set a very short attack time, just 20 milliseconds, so it's imperceptible, but it helps get rid of any weird artifacts that might be there. And then I also found that I needed to set a release time, because there were some of these events that would just get cut off, and that wasn't... it just sounded kind of weird. Something would be playing and it would just disappear suddenly. So I wanted to make sure that there was a sufficient release time and a fade down to 0 dB so that there wouldn't be anything that just seemed out of character for this event. So those couple of things really helped increase the overall variety of these sounds, because start offset means that we'll hear a different attack of these notes every single time, and the Ahdsr envelope made sure that that attack would be smooth and that the release of that envelope would not be abrupt or seem like it was just coming from out of nowhere. This first multi-instrument does exactly the same thing. The start offset values are a little bit different, but otherwise I'm using the same envelope in order to smooth those out. I didn't do anything with this third multi-instrument because it just sounded best to leave that one as is. And I just realized there's one other thing that I didn't talk about. All of these multi-instruments have a probability that's set. So this trigger behavior is a default for any instrument in Fmod, and by default probability is set to be off. So it looks like this, but when you turn it on, you have the ability to set the chance. And for each of these, I set the probability to 66%. So that means that there is a 2/3 chance that every time this instrument is cued, we will hear a note. But that means that some of the time we won't hear a note. And having longer gaps gives this melody a sense of phrasing, a sense that, you know, if it was played by a human, that person is leaving some room to kind of let the notes that they played have some room to breathe, to create some space before coming in with a new idea. And that worked well. 66% seemed to suit these notes and the overall thrust of this music. So I went with that. So that really kind of walks you through everything that's happening inside this Europa Melody. Let me open up the browser. It's not unused. I want to look at parts. You can see that a lot of these individual parts are listed as referenced. That's because they're here in the main event timeline, but that little arrow icon lets you know that it's a separate event. Referenced means that it's included in the same audio bank as this event. So it's part of the master bank. And our last referenced event is this other Europa Melody. This is the version of the Europa Melody that plays during the reprise It's similar to the other. It just does things a little bit differently. And I added some reverb onto the master fader to help enhance that sense of distance or space from this section of the song. So that walks you through absolutely everything that's here. And now that we've been through this and you know what it sounds like, we can save this file and build it and take a look and listen to how this might work in Unity and how it sounds when it plays in our driving tutorial. All right, we're back in Unity, and let's just take a quick look at the process of moving what we started in Fmod into Unity. Quickly, under the Fmod menu, edit settings. The project we were working with is here in the Studio project path. Once that's listed there, Fmod Events tab gives us a list of the events. Game Music Main is that event that we were looking at in the last part of this lesson. You can audition that here. We've got our started parameter that plays the stinger and allows us to get into the beginning of this song. Then we have our obstacle values. And again, these are showing up as floating point numbers. 0, 1, 2, 3, 4, and 5. So everything that we did in Fmod is here in Unity and accessible. Vehicle has an Fmod Studio event emitter attached to it with the Game Music Main event assigned to it. So everything is basically done and ready to go and exactly where we need it to be. Then once all of those things are in place, and these are all things that are covered in the earlier lesson, so if you're looking at this video for the first time and wondering what the heck I'm talking about, jump back to, let's see, this is lesson number 7, so jump back to lesson number 5, and I talk about this whole process of starting with a new music series of music events in Fmod, saving that, building it, doing the full Fmod integration package to get your Unity game up and running. It's all fairly simple and straightforward to do, and it's covered in Lesson 5. This one just kind of jumps in, assuming that those things are already in place, and it has an Fmod project that's just more developed than what I did in that 5th lesson. Well, in order to take everything that we have over here and get it to work with the game, we really need to look more carefully at some of the scripts that are in this project. So our vehicle has this player controller script attached to it. We can edit that script, and it's going to open it up here in Visual Studio. And I have the whole script open in this window, and I'm just going to go down top to bottom. This, again, is just a reiteration of a number of the other things that we've done in previous lessons. So there is no new code in this script. I was able to get the vertical adaptation of this I was able to get the vertical version of the music to work in this game without really having to make any significant changes to the code. It was just a matter of picking and choosing which parts of the code I thought worked best given some of the options that we've looked at in some of these previous lessons. So let's take a closer look. So yes, player controller script. The first thing we do is we tally the number of obstacles that we've hit. We do that with a public variable. It starts out with a value of 0, public so that it shows up in the inspector, and we can track it as we're playing through the game. We're not using this hit ID. That just doesn't work as well for this particular implementation. It could, but I just chose not to use it for this lesson. But because we are using the tag with a stinger at the beginning, I did want to bring this started Boolean variable back. So also public so we can see it in the inspector, although if we were going to do something with this game, there's no reason for it to be public. It can be private because everything's kind of contained within the scope of this object in Unity. But this variable just simply tracks, has the player started driving the vehicle down the road? At the very beginning of the game, no, so that variable is set to false. But we'll change it once driving begins. Then we give our Fmod Studio event emitter a name. And then once it has a name, we get access to it here in the awake function. And we just simply say, find the game component that this is attached to that has a studio event emitter, and refer to it by the name game music. Then moving down into our script, public float speed, turn speed, horizontal input, forward input, these are all default things that come from the original Unity lesson where we got this game with the vehicle driving down the road and smashing into crates. That's in the original lesson, which is also linked from the description here. The update function is where we do a lot of heavy lifting. Some of it is tied to just the basic mechanics of the game, like tracking horizontal input, making sure that the car will drive forward and that the car will turn in the way we want. But here at, this is line 41 in my code, I have some statements that really start to get into the specific interactions of this lesson. So in this block, we check to see check on the value of that started variable. And if we have not started, then we can step into this if statement and execute these statements. So it basically means if the player hasn't started driving, we can do the things that are in here. And simply what we want to do is test to see if the player has pressed the forward directional key. And if they have, its input will return a value other than 0. So if that's the case, then we step into this if block. We change the value of that variable to be true because they are now driving. And we also change the value of our started parameter to 1. That will cause it to play our stinger. So it finds that parameter value, started in our game music event and cues those components accordingly inside of the Fmod event. Then we have another function that takes care of a lot of the other essential components of this, and that's here in our on trigger enter function. So when we smash into one of the crates, it checks to see if that crate has the name obstacle, that game tag in Unity. If it is, we know, okay, this is one of the things that we're tracking in our music. For this implementation, I decided that I did want to use this line where after we hit a crate, we just simply remove it from Unity. So set active false is kind of the equivalent of deselecting that checkbox for an object in the inspector, and it just takes it out of the game world. It also increments the count variable. So at the beginning, we haven't smashed into any obstacles. Count is 0. Every time we smash into an obstacle, it will remove it from our game. It will add to the count. And then most importantly, it uses the current value of count here in this line and uses that to set the value for the obstacles parameter. So we hit our first crate, obstacles is now equal to 1, and Fmod's timeline will update accordingly and jump to the section where it's supposed to go. Play through all the automation in this vertical adaptive scheme and allow us to hear the development of the track. Well, that continues as as the count variable goes up to 2, 3, 4, 5. Every time we hit an obstacle, count increments, and accordingly, this is going to increment the value in Fmod, and we'll hear that music move through the arrangement that we've made and slowly and smoothly transition from one section of the music to the next. So that's really all it takes to make that work. It's a lot of heavy lifting in Fmod in order to get all those events set correctly and make sure that the various audio tracks balance out. But once that's done, triggering them and having them respond to gameplay events in Unity is really pretty simple, as you can see from this code right here. So now that you've got a sense of what's going on under the hood, let me go ahead and run this again and just kind of walk through slowly everything that's going on and verify that it's working as expected. So just for starters, we can see that our started Boolean is deselected. It's false. Count is 0 because we haven't smashed into any crates. I'm going to hit the W key and start driving forward, and you'll see this checkbox change, and you'll see the car start to move down the road. There we go. And we're now into the first section of our music, grooving along with this drum and bass. Hit our first crate. We hear the kashishi come in. Count is equal to 1. Drive a bit farther down the road. The berimbau comes in. Smash into our next crate. Value goes up to 3. Rhythmic synthesizer. Pick up another crate. Count is now 4. And we get that generative melody that's playing with the multi-instrument. Not happening on any particularly regular rhythmic interval. Always falls on a beat or a subdivision of a beat. But the more sporadic nature allows that melody to really kind of stretch into time without feeling overly repetitive or being predictable. Lastly, smash into a crate. Everything comes to a close, but then slowly fade back to our reprise. We can hear the low-pass filter doing its thing. You can hear how the Europa Melody has changed a bit. It's a little subdued due to the filtering, but there's also some reverb, and it's just not playing as much as it did when we were still in the process of smashing into crates. So to bring this lesson to a close, what we talked about is vertical adaptive music. And it's a unique use of Fmod because it puts the control of a DAW into your game so that you can smoothly change the mix and automate effects and make all sorts of other changes that smoothly adapt to the conditions or states of a game. This lesson really helps you get started with this, but there are some additional resources in the description that I think are worth checking out. The first is a tutorial by Scott Game Sounds. This is a great lesson that combines both horizontal and vertical adaptive techniques, and I highly recommend that you take a look at it because it shows you how to take what we've done in this lesson and what we did in the previous lesson and put it together into a single Fmod event. The other is the original lesson I did with Chance Thomas for layered loops. And this is part of the musical building block series that supports his book, Composing Video Game Music. Fmod was a different animal at the time that I made that video. So the Unity implementation that's in that lesson series is really pretty dated. But all of the musical concepts and ideas in the layered loops lesson are still very relevant and useful. So I recommend that you check out that lesson and also use the original audio files and just do some experimentation with vertical adaptive music schemes that you want to create on your own.